after the blue dextran, after you do the beta amylase and cytochrome C, the next thing we're going to be loading on here is our aldolase. We want to know what size our aldolase is. So just like we did with the beta amylase, we're going to remove all the solution on top. We're going to mix our aldolase solution with some 10% glycerol just to make it sit and go down the column nicely, because all of our other protein solutions had the glycerol stock in them. We're going to be loading our aldolase, and we're going to be collecting fractions after we load our aldolase. There's really nothing for you to see. You could see me loading it. You could see me collecting fractions, but it's not colored, so we're not going to show it to you on camera because there's absolutely no color to the aldolase. There's also no color to the other proteins such as BSA that you're going to be separating on this column. So all the rest of them after the first 2 times are colorless. So you'll just have to load them very carefully, collect fractions, read them at A280 in the spectrophotometer to say, okay, you know, it's in fraction number 20 and I'm collecting 1.5 mils per fraction. And so therefore it comes out at 30 mils, for example, as my elution volume. So then you can say my elution volume divided by my void volume and get that number and put it on the graph. So what comes in between doing all of your proteins is doing the aldolase. When you do your aldolase, don't throw your samples out, because your peak, that is going to be your S4 for your aldolase. So then you will have your S1, your S2, your S3, and your S4. The S1 is the protein that you saved the very first day. Your S2 is after the dialysis. Your S3 is after the phosphocellulose column. And your 4th sample, your S4, is after the sizing column. Your Bradford assay is very straightforward. What you're going to do is take a known amount of 1 mg per mil BSA, and you're going to add it to a tube and bring each sample up to a total of 200 microliters. So for your Bradford assay, you're going to be adding to various tubes 10 microliters of BSA, 20, 30, 40, and 50 microliters of BSA, and bringing all of them up to a total of 200 microliters. You're also going to have 200 microliters of water as a blank with no protein in there at all. So after you have done that, after you have added a known amount of protein and total of water up to a total of 250 microliters. So for example, if you're adding 50 microliters of protein, you would add 150 microliters of water for 200 microliters total. Then you're going to add your Bradford reagent, which is all ready to go. You're going to be adding 4.8 mils of your Bradford reagent into the appropriate tube, into all of your tubes. So what you have here is you have a variety of concentrations. So you have a blank with no protein in it whatsoever, 10, 20, 30, 40, 50 microliters of protein, getting basically more and more blue as we go along with increasing amounts of protein. So the key here is you're then going to take, after you've allowed your samples to react for 5 minutes and making sure that you've mixed them, you're going to take them to your spectrophotometer, and you're going to set your spectrophotometer to 595. And you're going to take your blank, so this is an example of the blank for the spectrophotometer. You're going to take your blank and you're going to put that into the cuvette, and you're going to blank it with the 0 protein. That is your blank. And then you're going to take that out, put in the 10, read it, take that out, put in the 20, read it, etc., all the way up. If it's too blue, if you have a solution that's very much bluer than this, like if it comes out to be bright blue or something like that, you're going to be out of range. So when you are, and for these, you know the amounts that you are adding up to 50 microliters. For your samples, you don't know how much protein you have in there. So for example, if you were to take 1 microliter of your S1 and add it in here, and then bring it up to 200 microliters of water and add the 4.8 mils of the Bradford mix, and it comes out to be bright blue, and you put it in the spectrophotometer and maybe it says 0.8. Well, you're out of range for that. So that would say use less protein. So if the first time you added 1 microliter, cut it back to 0.5 microliters. So you're going to get somewhere in your range of on your standard curve. On the other hand, if you do this with your protein, say you have your S4, which is a lot less concentrated than your S2. Say you add 2 microliters of your S4 and you do this, and you get 0.05. Well, that's too low. It's so low that it's out of range on the other end. It's on the low end of the range. So you would want to do it again and add a greater amount of protein, so that you're basically, for all of your samples, you have a sample with the Bradford of somewhere between 0.1 and 0.6. If you're over 0.6, you're going to be getting out of range. If you're under 0.1, you're going to be getting out of range. So somewhere in there. Make sure to allow 5 minutes for a reaction time. If you don't allow 5 minutes for a reaction time, you're not going to be getting accurate results. So after you add the Bradford assay, mix, and then 5 minutes. Okay, so this is an example of what your Bradford standard curve would look like with your 10, 20, 30, 40, 50 microliters of BSA done in that reaction, plotted on some graph paper. So you can see here's a graph of your absorbance at 595 versus your microliters of BSA. Now, the BSA is at a concentration of 1 microgram per microliter. So if you have 50 microliters, that means you have 50 micrograms of BSA in here, and you have at that particular absorbance. So then the next thing you're going to do is you're going to take a known amount of your protein. So let's say we've taken 2 microliters of your S2. We take 2 microliters of your S2, you add water to a total of 200 microliters, so that would be 198 microliters of water, plus 4.8 mils of the Bradford mix. Make sure you mix it, and then wait 5 minutes. After 5 minutes, then you can go ahead and read it on the spectrophotometer. So let's say that 2 microliters has an absorbance of 0.35. So that's about 0.35 right there. You'll do it more accurately when you're doing this on graph paper, and that comes over to 30 microliters or 30 micrograms of BSA. So if your 0.2 microliters has an absorbance of 0.35, that means you have 30 micrograms of protein in that 2 microliter sample. So 30 micrograms divided by 2 microliters, the concentration of your S2 is 15 micrograms per microliter. And you're going to be doing this for your S1, your S2, your S3, and your S4. And you're going to be combining that together with your specific activity assays, because remember, your specific activity assays, you have a known amount of protein that you get a rate of reaction, but you need to know how many micrograms of protein was in that many microliters that you chose that gave you a good rate of reaction.